All right. NET-200. We are on week 9, so this is covering all of week 9. So this would be Wednesday the 26th. The OSI model. Application hooked into whatever app you're actually running. For example, a browser or the app like a web server on one end or another. Present the data. For example, if it's a website, HTTP port 80 or secured 443, this means at this layer then it would be encrypted. Set up a session on both ends. Transport layer, how are we going to transport the data? UDP, TCP, and there's some other options that we'll talk about later on. We create a segment, it's got a port number, so then that segment becomes the data for a packet. Okay, so the segment's inside the packet has IP addressing, logical addressing, network layer, best path, data link layer, physical address, for example, like a media access control address, and here we call it a frame. Okay, call it a frame, and then physically it gets put on the wire or on the fiber or in the air to connect to the other physical part, which moves it back up a hierarchy. So when it gets to the other end, then it moves up the layers until it gets to the app. Okay, then that app responds, goes down the layers, then comes when it gets to the other end, and then back up when it goes end to end. Talk more about that later on. So let's move on. Regions to do. We talked on Wednesday about packet tracer, and the key things you have to have in there. You have to have the document, the actual instructions and so forth. Sometimes there's some items to fill in that, and that would be done in Adobe, right? You would download the document onto your PC, use Adobe to fill it in, and then you would upload it when you complete the work. You would also capture the results, capture that screen, make sure you click the assessment that it shows what's all done. Use Alt Print Screen, captures that screen. You'd put that in a doc, like a Google Doc. Put your name and all that stuff, any other information with that. And then that would get uploaded also. So you're going to upload this doc, you're going to upload the results, and then the actual packet tracer file, you're going to upload that. So there'll be 3 things. We talked about routers, Flash, NVRAM, and RAM. You should know those. Flash has the iOS. We talked about the startup config, NVRAM, and then what routers actually, the running config, what the router's actually using is in RAM, similar to a PC. We reviewed the skills-based assessment. Okay, everybody had a switch. It was connected to this multi-layered switch. So we had all those switches connected. And then that was connected to a router in which we did network address translation. And that sent the information through our network and allowed you to communicate with the internet, assuming you had your switch configured correctly and the PC on your switch configured correctly. If you scored below a 70, you need to see me, and we'll set up a time for you to take the test again because you need to know how to do that. Alright, so this information here, you have the OSI model again, you say, God, I'm familiar. Well, yeah, this is actually same class, NET-200, except now this is the 28th. Okay, so this was Friday, so this was actually today, the day I'm making the video. So I can go 10:28. So we went through this again. Our emphasis today was the network layer, but we reviewed it. Okay, so we said, let's say you have a browser and you're going to communicate to a web server. Okay? So, in the browser, you type in the URL, then DNS, right? DNS then will convert it into an IP address, and that's the IP address you're going to use in accessing the web server. So, the URL or the information, the request for information's in the data, and then here it would decide, right? Is it going to be encrypted or is it regular, right? HTTP, either HTTP or HTTPS, whether it's secured or not. Most, if we're just, let's say, not downstreaming anything, we just want to get to this website over here, okay? We just want to get to the website, and we have the URL. It'll run then through TCP. And TCP will create a segment. We'll have the port number in there. And if it's not, if it's just HTTP, that'd be port 80. Then we will add the IP addressing, source and destination. And there's some other information that goes in there, like priority of the packet, and what kind of packet, version 4, and so forth. We'll talk more about that in a little bit. Then this information, right, this information here, the packet then now goes down to the data link layer, becomes a frame, packet becomes a frame, and then it goes on to the physical. We already talked about the data link, you know, if it's a LAN, a wired LAN, then it'd go through Ethernet and so forth. And then it goes on to the media. Okay, sends it into the network, and there could be a variety. If this is, for example, the internet, if it's going through the internet to get to the website, it could go through these routers, these packets, you can think of it that way, going through the internet. Alright, then we come back, physical layer, they match up, so when it comes out, the last router it was in matches the physical layer here, just like this one matches the first router in, and then data link takes the framing part off, like the MAC address or whatever. Here it's going to look, in our case we're using IP4, it's going to look at that address, so that address belongs to this particular website, okay? Then it's going to go up through, correct either TCP or whatever. We said TCP over here, so be TCP here, the session, presentation, if it needs to be decrypted, and then eventually it hits the website. Then the website turns around, okay, we just accessed it, then it's going to send the HTML back, and then that'll come up to your browser. And if the page is too big to fit into one packet, it'll send multiple packets, and they may find a variety of ways to go through the network, and they get reassembled at the browser. Let's keep moving. So IP4, it has a header, it has the data in there, you know, at the network layer, you know, the data came down from up here, right, and eventually then here it became a segment, and then it was pushed down here, and then it encapsulated with the IP addressing. And if it has this, it's going to use version 4, right? This would be the priority, time to live. The packet starts at some number, depending, and 15, then it counts off as it goes through routers. If that ever gets to 0, drops the packet. Upper layer protocol, are we using TCP, UDP, or ICMP? And we have the addressing, 32 bits. And this is really key, you know. Everything's important in the packet, okay, but the addressing stays the same as it moves through a network, okay? And that's what the routers use. They use that destination IP address to know where to forward information to. Now, the new one, IP6, we have this increased address space, smaller header, and no NAT, so we don't have to do that network address translation. I'm going to talk more about that here in a minute. 128 bits compared to 32, which is huge. Okay, for example, this is the area of the Earth, and this is how many combinations we have with 128 bits. Literally billions upon billions every square meter. We have more addresses than we'll need on Earth anyway. Now, some terminology. Let's review terms. Encapsulation. When the data comes down, it gets encapsulated. Especially when you think about the transport layers, port numbers, network layer, it's going to put IPs. If it's Ethernet LAN, when it gets down to the data link layer, it's going to have a MAC address put on the outside. And then that's how it's going to get routed. IP is connectionless. When you, in this example here, when we started and we said, well, we have a URL and we're going to contact a website, it doesn't know we're coming. It's connectionless. And those packets move through the internet, and they could go different directions in order to get to the website. It's best effort. IP does not check to see if the packets are all there, or it doesn't. Now, transport layer, we're going to learn more about that later. It can check, but the network layer is best effort. Put it out there, see if it gets there. It can transmit across independent media. It works, when it gets to the physical layer, the network layer doesn't care how the physical layer is going to work, okay? Because it's just doing the addressing in the best path. So it can go through fiber, in the air, or through wire. A couple other terms to be aware of. Protocol data unit. Okay, we build these protocol data units. It's like the packet of what's going to be sent. And those can only be so big. Okay, they can only be so big. Now, IP version 4 doesn't have clean end-to-end connectivity. You start out with a private address, and then that is converted using NAT to a public address. Okay, then that public address is routed through, and then when it comes back, the conversions have to work the other way. IP6 will have end-to-end connectivity if you want it. And we'll learn more about that later on. All right. So we looked at those examples and we thought about it here a little bit. You have NAT, so we have a private address here, like 192.168x.x, whatever it be. And we can have the same thing up here, 192.168. And we did that. They did that. These private addresses, it's partially for security, and then we can take NAT and translate it into an address we can use on the internet. Okay? And our ISPs, all those addresses are divided up so there's never any conflicts. So we could have the same address here, but it won't make a difference because once it's in the internet, then it's going to be one of those public addresses. But we're limited and we're running out of public addresses. So we'll need to move to IP6. And when we do, we could probably, IP6, we could probably get rid of NAT, which we will, because we have such a huge range. All, instead of having a private address, everything can have an address. And that address can be tied with the MAC address, even though that won't be practiced, but it can be, so it can be easily to assign an address to all the devices. So you walk into McDonald's, the Golden Arches, and it'll give you an IP6 address based on, you can do it based on your MAC address. And then you're ready to go out to the internet. There are some concerns about that, and we'll talk more about that later. We assigned some routers, and I got another picture of that here I'm going to show. Okay, so then we did this lab, and instead of a PC here, we're connecting to a multi-layered switch. And everybody's routers are connected, everybody that was in class Friday. If you weren't in class Friday, it'd be a good idea for you to talk to me Monday after my programming class. Programming goes from 8 to 9:30. And so then you could get your setup so you can have everything ready for Wednesday. I reassign the addresses. So those addresses aren't exactly what we're using. I reassign those. And so I have a graphic here that okay. So these are the addresses. Now the people missing, just as an example, somebody has 12. I don't remember which student has 12. So if you were router 12 on Wednesday, that's what you would use here. 13, 14, 15, 16, 17. Okay. So whatever you had on Wednesday. There is no 20. Okay. So really you'd have to talk to me. And here's the setup. Okay. I'm going to assign addresses out here. You're connected, your router's connected here, at least everybody that was here on Friday. And then this is the address you're using to connect to the router. So you're a router here, and it would be one of these two interfaces, depending on the type of router you have. And then you'll fill in here based on your router number. And we're just doing that for convenience. Okay, so for example, Mariah, she's going to be using 11 for that one. And then your inside addresses, they're all listed with that 1. Well, you're going to take the 1 and add your addressing. So let's just say Chris's. So he'll use 117 for his inside address because he's router 17, and we're going to add that 1 in front of it. And it'll be one of those two interfaces depending on which router you have. So if you follow the lab, you should be able to do the configuration of the router, most everything, configure the switch. Everybody should know how to configure the switch. And then this part, we'll put the PC on Wednesday. But I've got a little configuring to do. When you get this configured, this router, eventually you should be able to ping out to the internet. And we'll work on that. We'll spend some time on that on Wednesday, and we'll finish up this chapter. Okay? We'll finish up this chapter on the actually the network, right? Network layer. Finish that up on Wednesday and start talking about IP addressing. That is it. Thank goodness. Have a nice weekend.